All right, welcome back, everybody. So we're going to finish up the digestive system today and hopefully have a little bit of time at the end of our class to talk about nutrition specifically. Before we get into that, Alex asked a really good question, kind of what was going on with COVID in our community, and I realized that I owed you a more data-based answer to that question. So Wisconsin Department of Health Services actually maintains a public data set that you can go in and look at yourself, which is pretty cool. And so I was like, okay, I have this anecdotal sense from my own experience of how things have been changing over the last month or so, but let's see if the data actually backs that up, because sometimes it does and sometimes it doesn't. So what we're looking at here is I put together a graph of weeks. So this is August 31st to September 7th, September 7th to the 14th, 14th through the 21st, and so on and so on. This is our most recent week, Monday to Monday, October 5th to the 12th. And so the blue bars are the total number of new cases of COVID-19 in Dunn County, right? So once Stout started testing, which is about September 8th, I think was our first day of doing testing, right? And then we added the testing of dorm students in the subsequent week. We saw a huge increase, right, in the numbers of cases in the county. Before, we'd never really seen more than 25 new cases in a week, right, all summer. So really huge increases. And as you can see, the vast majority of the cases, so 44 out of 54, 121 out of 131, 151 out of 171, were in people ages 10 to 29. Now you might be like, Dr. Hall, how many of those were Stout students? And the answer is I don't know. That information isn't actually publicly available. So on the dashboard, you can see how many people tested positive with a PCR test from the clinic. Although the results from people who were tested on Friday that come in over the weekend for some reason are not on the dashboard. So like, okay. And then you can see how many people had a positive antigen test down at the gym where they test the dorm students. Now, the antigen test, you might remember, is not as accurate and it's prone to false positives. So in somebody who doesn't have symptoms, who gets a positive antigen test, they do a PCR test. But the results of those PCR tests are not made public. So I don't know how many of those antigen tests were actually true positives and how many were false positives. So the only way I can get an idea of how many might be Stout students is by looking at age decade. So there's a 10 to 19 and a 20 to 29 in Wisconsin's data set. So I just combined those. So obviously the vast majority of cases were occurring in people in your age group. But what we've seen, so this gray bar is age 30 to 69, right, is that as there's more COVID in the community, and of course our students are part of our community, right? You go to restaurants, you go to bars, you go shopping, you socialize with people who aren't students, at least some of the time, some of you, right? We're starting to see an increase in the numbers of people my age, right? So 30 to 69. So this last week, right, about 42% of all the cases were in people who are older. So although overall cases have gone down significantly for now, which is great and wonderful, we have to keep an eye on how many people in the older age groups are getting COVID because, of course, these are the people who are at increased risk for serious illness. And so one of my colleagues actually who works at the clinic, and of course at the clinic we see people who have COVID-19 like all the time, especially these weeks, we saw a lot, right? But we wear N95 masks and face shields and gloves and we have all the stuff, right? But her husband went on a hunting trip and stayed up in a cabin with some buddies of his and came home sick. And now she's sick. They both have COVID. And she just got admitted to the hospital about an hour ago. So this is what we worry about, right? Most people who are young do totally fine. Some get pretty darn sick, but most do totally fine, right? But when we start seeing more of it in the older age group, that's what we worry about. So I want to thank you all. It makes me so proud when I am out downtown and I see all the students walking around with their masks on. So I just want to say like a huge thank you to you because you show that we can do this It's not the end of the world to have to wear a mask when you go out and about, right? And you set a really great example for the rest of the community. All right. So here's hoping she does all right. So I couldn't not address this because this showed up on Facebook this week because, you know, I'm old, so like I do Facebook, right? And it just ticks me off. And I just want to use this as an example to reinforce some of the concepts we talked about way back in the first lecture. So kind of understanding science and scientific data. This is a guy who says, take off the masks, they're making you sick. And here's a screenshot from a published article on the CDC website. And so what they've highlighted here is reported use of a cloth face covering, right, a face mask. And these are people who tested positive. And he said, look, 70% of the people who tested positive for COVID said they always wore a face mask in situations where it was recommended. So obviously masks are making you sick. Ugh. Here's why this ticks me off. He's wrong. That's not what this study shows. So let's look at what it actually shows. This is a case control study. What they did was they looked at all these people that came to various clinics to get tested for COVID, people who had runny noses, sore throats, fever, headache, fatigue, whatever, and got tested for COVID. And they said, okay, of the people who ended up testing positive, what characteristics did they have, and in what ways did that differ from the people who ended up testing negative, right? So trying to see what are the risk factors that make it more likely that you will get COVID. So the people who tested positive are what we call cases, right? So I've highlighted those in red. This is the data on the cases. These are people who tested positive for COVID. In the green, these are the controls. These are the people who tested negative. So we're looking to see if there are differences between the two groups. So he highlighted the mask wearing. So 70.6% of the people who got COVID said they always wore masks in situations where it was recommended. 74% of the people who tested negative said they always wore masks. So you might say, see, if you were negative, you're more likely to be a mask wearer, but you've taken this course and you know to look at the p-value. It's greater than 0.05. There's no statistically significant difference in the mask-wearing behavior of those people who ended up testing positive and those people who ended up testing negative in this study. Now, both groups had very high rates of mask wearing. That's pretty darn good. So what was different between these two groups, right? Because that's what we want to know, right? That's what we're going to look at to figure out what increases your risk. So look at these p-values here, less than 0.01, highly statistically significant. This one, were you a close contact with a person who had known COVID-19? 42% of the people who ended up testing positive, they were a close contact, whereas only 14.5% of the people who tested negative were close contacts. This totally fits with what we're seeing clinically. This fits with what we're seeing at student health services, right? It's like, oh, well, my roommate got it, so then I got it, right? Or my boyfriend got it, so then I got it. Because a lot of times your close contacts are the people that you hang around with without a mask on, right? Okay. The other thing that was different, right, is among those who had close contacts, a very high proportion of people who ended up testing positive, it was family members, right? As opposed to like somebody at work, right, or some other random person. So obviously, if it's your family, you're not wearing a mask around them. This makes sense. This is not earth-shattering. Okay. The other thing that this study found, and it was interesting when it came out last month, and it's part of what actually informed the governor's emergency declaration to reduce capacity in bars and restaurants, which has since been put on a stay by a judge because he's being sued for it. But this is part of the reason why he did that, is because when you looked at the people who got COVID and the people who didn't, there was a statistically significant difference, not only in the fact that you went to a bar or a restaurant, but also that the ones that you went to, nobody was wearing masks or keeping distance, right? So the people who tested positive, 20% of them went to places where nobody was masking or distancing, whereas only 2% right? The people who didn't get COVID, right? Same thing with the bars, right? So one other thing that the study showed is that overall, going to a bar or restaurant significantly increased your risk of getting COVID. So this is your restaurant here. But it was cool because it showed that going to a hair salon or going to work or going shopping, right? Using public transportation even, the only things that were associated with an increased risk of testing positive for COVID were restaurants and bars. And this makes sense because if you're going to some place where you eat and drink, you take your mask off, right? Makes sense. So that's what that study showed. Here's all that information in one slide, all right? So what we find is the people who got infections are getting them from close contacts where they don't mask, right? From family members, roommates, and restaurants and bars. So thank you for wearing your masks. They really do help. All right, are we ready to get back into the digestive system? All right, any other questions about COVID before we move on? All right. So when we talked about the digestive system, remember I was like, I don't really like the name because it doesn't just digest, which means to break down food particles into their smaller bits, right? And we do that both mechanically, meaning just physically breaking them down, and we also do that chemically using enzymes to actually break the molecules apart into their smaller subunits, right? But we also have to then absorb those nutrients, bring those subunits, those amino acids, those monosaccharides into the body, right? So it's really the digestive and absorptive system. All right. These are all the things we talked about last time. Thought it might be nice for you to have a summary slide, okay? I'm not going to go through it, all right, except to point out that, of course, remember we talked about the alimentary canal is the muscular tube through which food moves through. So the esophagus, which is just a transport tube, and the stomach are part of that canal. But the liver, the gallbladder, and the pancreas are accessory organs, right? They're off to the side, and they squirt stuff into the intestines. All right. And the pancreas is the bomb because it makes enzymes against all 4 classes of macromolecules. All right. Let's talk about Sylvia. She's been trying to lose weight. Diet and exercise really aren't cutting it, which is not a surprise. They don't really work long-term for 90% of people. So she decides to try something else. So she sees an ad for it, and she goes to the store, and she buys this thing called Ally. Right? It's called Orlistat. They're these capsules. And so she starts taking them as directed and notices some side effects. Like all of a sudden she's getting a lot more gas, and she's farting a lot more, and she's having kind of oily diarrhea. And sometimes she's even having some accidents, right? She's kind of sharding. So she's like, this is not cool. And so she goes to the clinic and she's like, what's going on? Am I allergic to this medicine or something? Right? And then we say, actually, no. The reason why you're having these symptoms is because the medicine is working as intended. Okay? So let's take a look at what's happening in her small intestine. So this is all about the small intestine. So the small intestine is a long, coiled muscular tube that's all coiled up and packed into your belly. If we stretched it out, it's about 18 feet. We divide it into 3 parts. They're not hugely distinct visually. The first part is called the duodenum, and that's the smallest part. So from the stomach, food is going to move into the duodenum, which is kind of the C-shaped part here. And then from there, it continues into the small intestine, into the jejunum, right? And then down into the ileum. And then eventually it's going to go into the large intestine. So that's the small intestine. And it is probably the most crucial part of our digestive and absorptive system. So the small intestine is going to do both things. It's going to digest, break food down into its smaller subparticles, and it's going to absorb. In fact, it is the main absorptive organ in the whole system. You cannot live without your small intestine. You can't live without a lot of things, but you definitely can't live without your small intestine. So, what is all this about? In order to do its job well, the small intestine needs to have a lot of surface area. right? So I already mentioned that it's over 18 feet long. It also is arranged into folds like this. So if this is the inside of the tube, like imagine like a corrugated tube. And that's going to help increase surface area, right? Because then, you know, in this little bit of space, I've got all this surface area. So I'm going to have all these folds. And then each one of these folds is going to have these little finger-like projections on it, like bristles on a hairbrush. These little fingers sticking up. So each one of those adds additional surface area. Then each one of these finger-like things, which are called villi, right? So we have these villi, and it's shown right here. This is one single villus. Villus is singular. So here's the folds. On top of each fold, I have multiple bristles or finger-like projections called villi. And the outside of the villus is lined with simple columnar epithelial cells. Each one of those simple columnar epithelial cells has on its head, on the top of it, little microvilli. So additional little finger-like projections sticking up on the top of the cell that further increase the surface area of the cell. Okay? So the small intestine is intentional, well, not intentionally, but it's designed to have a ton of surface area, right? We have the folds, right, that allow us to pack in more surface area. We have the finger-like projections called villi, and then all of the cells lining the villi have little microvilli on the tops. So we can maximize surface area. All right, so structurally, it's really cool. All right, so I kind of think of it like if you had a shoreline and you wanted to be able to park a lot of boats there, if you don't have a marina, you can't fit very many boats along the shoreline, right? So we create these long docks, right, that then have other docks coming off. Look at all these boats. There's no way you could park all these boats if you just lined them up in a row here along the shoreline. Same thing with the small intestine, okay? We're adding architectural detail so that we can increase surface area. This is a close-up of another one of those villi. So you can see, again, those simple columnar epithelial cells. There are also some goblet cells here. And each of those epithelial cells has microvilli on the top. So I mentioned that the small intestine is going to both digest and absorb. So let's talk about the digestion piece. So we're really talking about chemical digestion here. We've already done a lot of mechanical digestion with our teeth and our tongue and our saliva and the stomach, churning it all into chyme. When we arrive in the small intestine, we were gifted with enzymes from the pancreas. So remember that exocrine function of the pancreas is to squirt enzymes, amylase, lipase, and trypsin, which will digest carbohydrates, lipids, and proteins, right? So the pancreas is going to squirt that stuff into the small intestine. So that's one source of enzymes in the small intestine, is what got squirted in there from the pancreas. The other source of enzymes is those microvilli themselves produce enzymes. And sometimes people call the microvilli the brush border. So they'll be called brush border enzymes. Okay, so those cells are also going to make enzymes that stick right there on those microvilli. So we have two different sources of enzymes for the small intestine. That means business. All right. So we're just going to remind ourselves that when we're doing chemical digestion, we are breaking bonds. So that's actually called a hydrolysis. You add a molecule of water, splits those subunits apart. So hydrolytic enzymes, hydrolysis, splitting using water. So carbohydrates break down into saccharides. The smallest ones that are just one subunit are called monosaccharides, right? Mono meaning one. Our lipids get broken down into what? What's the subunit for a lipid? We're very quiet today. I'm sorry. You're writing stuff down. All right. So lipids get broken down into fatty acids. Oops. I'm out of order, right? And proteins, as you know, get broken down into amino acids. And the whole reason we do this, and that we have all these enzymes to help us do this, is because we can't absorb a big old chunk of steak into our bloodstream. Right? We need to get them down into the smallest molecules so that we can actually move them across the cells and into our bloodstream. So once we break these molecules down into their subunits, then we can absorb them. They're finally small enough that we can cross the cells and enter the body itself, okay? The inside of the body. So let's talk about what that looks like in the small intestine. So here's another diagram of a villus. Here's that finger-like projection lined with those epithelial cells that have microvilli on top. Here's a microscopic image of the same thing. So this is actually looking at this underneath the microscope. Each one of these is a villus, a finger-like projection, okay? And these are the simple columnar epithelial cells. It's really hard to see. If we zoom in, there they are. There's one cell. There's a goblet cell. There's another cell. And you can see this, you can see why they say this looks like a brush border. It almost looks like a little fringe on a rug or something. Those are those microvilli. Inside the villus, we have two important structures. Inside the villus, we have a blood capillary and we have a lacteal. A lacteal, you would think, oh, it has something to do with milk. Unfortunately, no, it doesn't. Well, they thought that the fluid inside of it looked kind of milky, so that's why they named it a lacteal, but it has nothing to do with milk per se. A lacteal is the smallest of a lymphatic vessel. So you might remember way back when we talked about lymph, it's that kind of fluid and it drains through lymphatic vessels. A lacteal is a tiny lymphatic vessel. So we've got both a blood capillary and basically a lymph capillary, a lacteal. So we have two inside the villus. So what's going to happen is our carbohydrates and that break down into their monosaccharides and our proteins that break down into our amino acids, those are water soluble. Those are polar molecules. And they can rather easily move across, there's like all the simple columnar epithelial cells are here, move across the cell and get into the capillary. No problem. Okay? So amino acids and monosaccharides will get absorbed into the blood capillary inside the villus. Bigger fats are different. They're a problem. So larger lipids get combined with proteins to form something called a chylomicron so that we can deal with them because they're nonpolar. So we give them a protein chaperone. We call that combined molecule a chylomicron, and that's going to move into the lacteal. So our absorption of fats is different than our absorption of amino acids and saccharides, proteins and carbohydrates. All right. These capillaries are then going to end up draining into our general circulatory system, but not before going to the liver for processing. So all of these capillaries in the villus are going to drain into veins in the intestines and then go into that hepatic portal vein that we looked at last time when we looked at the liver, because the liver has to process all the nutrients and wastes that are coming in that we've absorbed from our intestines before the blood can then go into the bloodstream. The lacteal, the fluid is going to go through the lymphatic system and end up getting dumped into the veins just upstream from your superior vena cava. So what's really interesting is if I test your blood cholesterol and you just had a bacon double cheeseburger and a chocolate milkshake, your blood, no joke, if I let it sit, a big thing of fat will form on the top of it. It's quite something. I'll find you a picture for next time. It's quite something to see, right? Because the fats just get dumped into our blood, and then our liver has to deal with them like through the normal circulation instead of the special intestinal circulation. Why did we develop that way? I have no idea. But there we go. Probably because lipids aren't water soluble and it creates all kinds of problems. All right. I like the diagram in your book better There's a really good diagram in your book of this process that I couldn't find an electronic version of. But this is showing us the same thing. So what we're starting with way up here at the top is our carbohydrates, right? So in the mouth, we have salivary amylase, which if it's a complex carbohydrate, will start to break it down into smaller bunches, smaller chains of those saccharide subunits. Of course, if we take in some sucrose, some table sugars, some lactose, right, those are already pretty small. No digestion of carbohydrates in the stomach. When we get into the small intestine, we have some amylase from the pancreas. We also have some additional enzymes in the brush border on those microvilli of the simple columnar cells. So we get it all the way down into mono and disaccharides, right? Glucose being a monosaccharide. And those get absorbed into the blood capillary inside the villus, excuse me. Proteins, right? Huge long string of amino acids. They start chemical digestion in the stomach, right? That's the only molecule that we start chemical digestion of in the stomach with pepsin. So we start breaking them down into their subunits. Then when we enter the small intestine, we have trypsin and some other enzymes from the pancreas to break them down even more. And then we have additional enzymes on the brush border. So by the time they come into the cells of the lining the villus, they are individual amino acids. And then they move right into the bloodstream inside that capillary, inside the villus. Fats are different, okay? No real chemical digestion of fats happens until we get, I mean, they're talking about there's a little bit of lipase, but we're conveniently skipping over those. The pancreas makes lipase, right? It's going to break them apart. And the bile salts, you might remember we talked about bile being important for emulsifying lipids, right? And making sure it disperses and becomes able to be solubilized, dissolved in water. So when bile attaches to fats, it forms these things called micelles. Not like M-Y cells, but M-I-C-E-L-L-E-S. Those move into the cell. They get turned into those chylomicrons, right? They get a protein chaperone, and then they move into a lacteal inside the villus. So remember, fats are different because they're nonpolar. They don't dissolve in water. They require special handling. All right, so you've forgotten about poor Sylvia now. Okay, so why was Sylvia having such a hard time? Why was she sharding? So the poor Sylvia, the way Ally works is it blocks lipase. That is its function. That is its mechanism of action. So what that does is it prevents you from chemically digesting lipids. If you don't digest something, it continues through your intestinal system. It can't be absorbed, right? Hence the greasy, oily diarrhea. Okay? And when we have really greasy, oily contents inside our large intestine, the bacteria there kind of go crazy, and you get a lot of farting too. And it's much harder to control really kind of greasy, liquidy stool than it is solid stool. So you also get accidents, right? So that is how Ally was actually even designed to work, right? You could eat all the cheese you want, and you don't absorb any of those fats. They just go right through you, right? So the problem with Ally is that in order for it to work, you have to take a dose that's high enough that you basically have trouble with diarrhea and flatulence and accidents in order for it to actually work. The other problem is that any short-term weight loss effort doesn't work long-term. Fewer than 10% of people can maintain weight loss over time. All right. Let's talk about Simon. Yeah, question. Yeah, so why does 90% of the time, if you follow people out over time, there's been some really good longitudinal studies. So, if you watch The Biggest Loser or something like that, it's like, oh, it's very simple. It's calories in, calories out. Well, to a point, right? So yeah, you can lose weight in the short term. But we are evolutionarily designed to withstand famine. Right? Our bodies have incredible ways to deal with significant decreases in energy intake. And so what we see happening, right? So if a standard person about my size who's fairly active, right? So they maybe burn about 2,000 calories a day. That would be their normal caloric requirement in terms of energy, right? We also have other requirements in terms of nutrition, but just in terms of energy. If I go on a diet for a period of time and I lose a lot of weight, and the vast majority of people, what happens is your metabolism changes. Your body starts trying to be much more efficient. And if you measure how many calories my body is actually using per day, it goes down to about 1,400. I'd be like, well, how is that possible? Right? So what the body does is it says, there's not enough energy resources around. So we're going to stop spending energy resources on things that are not crucial to survival right now. We have all kinds of compensatory mechanisms. My body temperature will go down. My heart rate will go down. My blood pressure will go down. I will stop maintaining my bone. I could live off the bones that I have for like a good 3 to 5 years. Right? It's like, the roof is looking a little ratty, but let's put it off. We don't have enough money in the bank account to pay for a new roof yet. I'll also shut down my reproductive system. Right? I'll also feel really tired, and it'll be harder to do activities. So what we see happening is the body shifts into a hypometabolic state. The body starts trying to conserve resources and not spend money or energy on things that are not essential for survival. So there's a really good study that they did out of Brown University and said, what are the characteristics of those people who have lost weight and kept it off, which in general is about 10% of people are ever successful at doing that. And in those people, the factors that they found to be associated with success are they weigh themselves every single day. They write down every single thing they eat, and they measure it carefully. So there's rationing. They exercise every single day. And in general, they're only operating on about 1,400 calories a day. So those first 3 things I talked about, weighing yourself every day, writing down every single thing you eat, keeping really close track of it, and making sure you exercise every day, those are actually criteria for an eating disorder, potentially, right? So it doesn't work for the vast majority of people. But that isn't what most people want to hear. So that message is usually very unpopular. You don't hear it a lot. So it makes a lot of sense, calories in, calories out. But the body is really tricky, super tricky. It's a thorny issue. Good question. Other questions about that? Yeah.
If there was a person who was really skinny trying to gain weight,
Yeah.
it's having trouble with that.
Yeah.
It's the same problem for people who are obese.
Right. So people who are really skinny and have trouble gaining weight. First of all, we always want to make sure that there's not something wrong, right? That they don't have like celiac disease, or they don't have thyroid problems, or they don't have a medical condition that makes it hard for them to maintain a normal weight, right? But then there are some people that are just like, it's just like hereditary. Like some people, they're just like made to be skinny. That's just normal for their bodies, right? So there, you can try to trick the body if you want to try to get more calories in. Juice is good, right? Caloric beverages are a good way to try to sneak in extra calories without a lot of volume. But yeah, there's not any great answers. Yeah. Bodies are tough. They want to be what they want to be. All right. There's also some really interesting stuff that has to do with the microbiome and body weight. There's a lot of interesting stuff out there. We could do a whole course on it. All right. But instead, we're going to talk about Simon. He has celiac disease. You've probably heard of celiac disease. Celiac disease is different from gluten intolerance or gluten sensitivity. Celiac disease is people who are allergic to gluten. All right, so what does that mean if you're allergic to gluten? Well, if he's eating this bread, he will get abdominal pain and he might also get diarrhea. Right? Because he is allergic to it. And what it means to be allergic to something is that your immune system is treating something that's harmless as if it is a pathogen, as if it is a germ or a microbe, right? So your immune system is attacking something that it shouldn't normally attack. So in celiac disease, right, the immune system is improperly or excessively attacking the gluten. And the thing about it is, your immune system doesn't really see the gluten until you bring it into your intestinal cells. And then the immune system goes, right? And then turns your intestinal cells into a battleground. And this causes damage and scarring. So when we look at the small intestines of people who have celiac disease who are eating gluten, is that instead of seeing these nice, long, finger-like projections of villi, their villi are all practically gone. They're all just swollen and scarred down. So what happens is, A, their stomach hurts because their immune system is constantly attacking their intestinal cells. And B, if it's severe enough, they have such a loss of surface area that they can't properly absorb nutrients. And anytime you don't properly absorb nutrients, you have diarrhea. Has anybody ever done the milk gallon challenge? Okay. So, you didn't hear it from me, but if you want to make an easy $50 and you don't mind causing a friend too much harm, you can bet them that they can't drink a gallon of milk in an hour. Seems like that wouldn't be that bad. Why is that going to be a problem, to drink a gallon of milk in an hour? It's a lot of milk. What sugar is in milk? Lactose. And those of us who are not lactose intolerant have an enzyme that breaks lactose down. That enzyme is called lactase. But you only have so much of it. And believe me, you don't have enough to break down a gallon's worth of milk. Yeah, we tried this in medical school. Richard Kim, man, he tried so hard. Right? But you can't do it. You end up in the bathroom having really bad cramps and diarrhea. You can't drink a whole gallon of milk, I promise you. Okay? So anytime you can't digest something well, you're going to get abdominal cramping and diarrhea. That was the lesson behind that. All right, so back to celiac disease. This is what it looks like. So this is a normal small intestine. We've got these folds, and they have this glistening kind of velvety appearance to them. That's the microvilli. Think of it like velour or velvet, right? Those little those villi give that velvety appearance. But somebody who's really sick with celiac disease, who's been eating gluten, ugh, it's all inflamed, it's flat. Those villi are just obliterated. They have lost so much surface area. So the good news with celiac disease is if you just don't eat gluten, it'll heal. Best thing ever, right? But then no donuts, which really kind of sucks. I just got diagnosed with this last January. Man, I feel a lot better, but I miss my cookies. The gluten-free ones are just not the same. All right. Let's talk about Lydia. Ignore all this text. So Lydia just moved to Wisconsin from out east, and she's totally psyched for the cheese, right? So she's a freshman, and so she's eating a lot of cheese, and she's living in the dorms, and it's kind of weird going poop in a bathroom where there are other people, right? And so what she notices is that over the first few weeks of the semester, she's getting kind of more and more constipated, right? So she's like, what can I do, right? Is it just that I'm not making good food choices, or is there something else going on? So this is our introduction to talk about the large intestine. So the large intestine is going to receive all of the food contents that were coming through the small intestine that haven't been absorbed, that haven't been digested, broken down into smaller parts, and then absorbed. So basically, it's going to receive the wastes, right? This is the stuff that we can't digest or absorb. So it's going to move into the large intestine, and we name the different parts of the large intestine, which is like this big upside down U with a squiggle at the end. This first part is called the cecum. Then we have the ascending colon, because the material in it is actually going to go up. And then transverse, because it's going to go across. Then descending, because it comes down. And then the sigmoid, and then the rectum. One really interesting thing about the large intestine is that it's one of the few parts of that alimentary canal, that digestive tube, that can do reverse peristalsis. Right? So we talked about peristalsis as being that process of muscular contractions along that tube that push the food products or waste down through the tube. Right? So even if I'm up on the space station, food is still going to move through the way it's supposed to. There are two parts of the digestive system capable of reverse peristalsis. I just told you part of the large intestine is one. Any ideas as to what the other one is? You've all had personal experience with this, most likely. When do things ever go the opposite way? Yeah, when you vomit, right? So the stomach is also capable of reverse peristalsis, right? We think it's kind of a survival mechanism. If you eat something that's bad, you can like vomit it out, right? Too much alcohol, vomit it out, right? But the rectum also is too. So the way it works is really interesting. These waste materials get moved through the large intestine, and they arrive in the rectum. And when it arrives in the rectum, you have this feeling, and you go, oh, I think I need to go poop. But then perhaps you say, but I'm right in the middle of this fascinating digestive system lecture, so now is not the time, rectum. And so your rectum's like, okay. And so it's going to push the material here back up into the sigmoid colon. And then you will lose that sensation of feeling like you have to go to the bathroom. And in fact, if you maybe try to go to the bathroom right after class, you're like, I missed my opportunity. All right, and you have to wait again until it comes down into the rectum again. So, kind of cool. Can do reverse peristalsis, which is nice because then we're not sitting around being uncomfortable, feeling like I have to go to the bathroom. All right, what does the large intestine do? The main thing that the large intestine does is absorb water. Because when the contents from the small intestine enter, they're still pretty watery. And then we would have diarrhea all the time, and that's harder to control. So the main job of the large intestine is to absorb water and some salts, right? And helps make some nice formed solid stool for us. The other thing that it does, which we're increasingly learning is super important for us, is it houses bacteria. And they're called the intestinal flora, and they are part of what is now being called the microbiome, which is all the bacteria that live within and on us. And these bacteria actually do some really important things for us. It's so cool. So they eat the stuff that we can't digest, like some of the fiber and starches that we can't digest and break down. And what they do when they're sitting in there is they actually make some of our vitamins for us. So about half of your B complex vitamins and about half of the vitamin K that you need, your bacteria make for you. In fact, we know this. Sometimes if I treat somebody with antibiotics and there's somebody where I'm worried about their vitamin K level, their vitamin K level will drop because I treated them with antibiotics. We're also realizing that they have some really important functions, not only for our metabolism, so I kind of mentioned when it comes to kind of metabolism and weight regulation, all that kind of stuff, they're important. They also produce some neurotransmitters, which are important for mood, and they also help regulate our immune system. Like, it's really amazing all the things that these bacteria do. And so we're learning more and more that in certain metabolic problems, like in type 2 diabetes, for example, we find that people have a shift in the types of bacteria living in their large intestine that ends up creating these kind of metabolic problems for them, which is amazing and fascinating, right? We've been kind of been like, oh yeah, that's just the normal flora. They're just sitting there. They're just eating what you don't want. No, they're actually symbiotic with us, right? They actually are performing important functions for us that we're only just starting to learn about. It's really cool. All right. So, of course, it's also going to control the passage of stool. I already kind of talked about this, right? So it's going to push things through as it absorbs the water. So as things move through the colon, they become more and more solid, right? And if something comes down and you're like, oh no, somebody else just walked into the bathroom, I'm not going to go poop right now, right? And so you do reverse peristalsis, then it's going to hang out here a little bit longer. And more water is going to get absorbed out of it. So, if you routinely or frequently delay defecation, meaning when you are like, I need to go to the bathroom, and you're like, oh, no, I'm not going to go now. If you do that a lot, right, you end up getting drier, harder, larger stool. And that is harder to push out, right? So that can lead to constipation. So, there we go. All right. So that's part of Lydia's problem, right? She was really shy about using the restroom. But the other thing about Lydia, she's eating a lot of cheese, and cheese tends to be pretty constipating just in and of itself, and not eating a lot of fibers. The one thing we haven't really talked about yet is fiber. I mentioned it briefly when we talked about complex carbohydrates, right? Some of them we can't digest, like cellulose. That's fiber. And what fiber does for us is it helps add bulk to the stool, and it is also osmotically active and keeps some of the water and the moisture in the stool so that it doesn't get too dried out. So fiber is actually really important for staying regular. So if you tend to get constipated, you want to lay off the cheese and the bananas. They tend to be constipating. And you want to incorporate lots of high fiber foods into your diet. Fruits and vegetables, whole grains, oatmeal, right? Or even a fiber supplement, okay? Also make sure you get enough water. All right. Colin, he recently had a bad skin infection. We had to treat him with antibiotics for a couple of weeks, right? And since then, he has crampy abdominal pain and really bad smelling diarrhea. Why does this happen? This is a known side effect of antibiotics. And it's because we're killing off some of those healthy bacteria in your intestine as well, right? So abdominal cramping and diarrhea are potential side effects of any antibiotic, pretty much. This is why sometimes we'll recommend that you take a probiotic or eat a lot of yogurt to try to get some of those healthy bacteria back in your body. Okay, the appendix. The appendix is this little tiny worm-like thing off the cecum, or off the first part of the large intestine. So Abby gets appendicitis, pretty common, not uncommon in your age group. We probably send a couple of students over to the hospital every year to get their appendix out, right? So they removed it, and now she's like, well, is this going to be a problem? Like, I'd assume that's a body part that I had. What was it doing for me? Is it going to be a problem that I no longer have one, right? Can you live without an appendix? Yes, you definitely can. Here's the appendix here. And many people do. It's this little tubular structure, and we don't really know what it does. Obviously, a lot of people seem to live just fine without it. There's this idea that it maybe serves as a reservoir for those normal bacteria, right? So that if you take antibiotics or something like that, it kind of serves as a little thing off to the side where you save some that then you can use to repopulate the intestines. I don't know, maybe. There's not a lot of evidence to support this idea, but it's a current idea that's out there. All right, this is it. Here's your whole digestive system in one chart. So let's Kahoot. All right. So when we talk about nutrition, we're talking about getting in the things that you need to be healthy as a human, right? And so what are the types of molecules that we need to bring into our bodies? So First of all, I know this is a lot of text, sorry. We have to eat those macromolecules. We have to eat proteins, we have to eat carbohydrates, and we have to eat lipids. And it's for different reasons. So let's look at them one by one. So carbohydrates primarily are an energy source for us. They're a really good source of energy. Anyone who's done carb loading before a big athletic event knows, right? They break down into glucose, which is what we use for aerobic cellular respiration in our mitochondria to make ATP. So they're an amazing energy source for us. They also, in the complex carbohydrates, provide fiber, right? That's why you want your fruit and your veggies. That's why you want your whole grains, your whole wheat bread instead of white bread, because that fiber helps your intestine to function well by adding bulk to the stool and also retaining some water. It also will bind to certain toxins and to cholesterol. So if you've ever seen the little thing on a box or a tub of oatmeal and it says it will reduce your cholesterol, it will actually. It will bind to cholesterol in the lumen or in the inside of that digestive tube and prevent you from absorbing it. Absolutely. Okay? So fiber is also really important for us. Our digestive system can't function well without it. Proteins, the reason why we need to eat proteins is because they give us what are called essential amino acids. Now, so amino acids are the building blocks of proteins, and it just so happens that of the 21 or so different types of amino acids, we as humans are able to make some of them, but others of them we cannot make. So the only way we can get them into our bodies in order to manufacture the proteins we need is to eat them. So the ones that we can't make that we must eat are called the essential amino acids. So you have to eat protein because you need those essential amino acids. Okay? Technically, you don't have to eat carbohydrates, but it would be really hard to get enough energy if you never ate carbohydrates. And then you wouldn't have fiber, so you'd be a constipated mess. All right. Why do we need to eat lipids? Well, it turns out that just like there are some essential amino acids, there are also some essential fatty acids. So there are some fatty acids that we need to use in our bodies for manufacturing certain molecules for the parts of cells that we can't make those fatty acids ourselves. So we have to eat them. It is absolutely unhealthy to eat a completely non-fat, no-fat diet. You will get sick. Okay? You have to eat some lipids. You have to get your essential fatty acids. All right? Lipids are, of course, a great energy source. Right? They're one of the most energy-dense molecules that we can have. So we get energy from them as well. Proteins we don't generally use for energy. We can if we have to, but we don't generally. Right? We'd much rather use those amino acids to build other proteins with. Right? We don't want to waste them on energy. All right. So where do we get our carbohydrates from? So our simple carbohydrates, the mono and disaccharides, those are what you think of as your sugars. Right? So glucose, fructose, sucrose, lactose, right? They're found naturally, of course, in fruits and milk and lots of things, carrots. But then, of course, we refine some of them, right? So they're in candy and soda and all that kind of stuff too. So they can cause your blood glucose level to go up really high, really quickly, because you can absorb them really rapidly. And if you do that a lot over time, that's not so good for your body. It might increase your risk of developing diabetes down the road. So in general, we don't recommend you eat a lot of these, right? Because all they're giving you, too, is energy. There's no other nutrients that you're getting. All right. So those are our simple carbohydrates. Very tasty. What about our complex carbohydrates, right? So these are going to be much slower release. It's going to take them much longer to be mechanically and then chemically broken down into glucose, right? So this is going to give you a longer, more sustained source of glucose, right? Rather than a huge spike and then a crash. And so we're going to find complex carbohydrates in grains, right? Like wheat and oats. And the nice thing about grains is not only do they have these complex carbohydrates, but they often have other important nutrients. So in case of whole grains, right, we're going to find vitamin B or thiamine is present in a lot of whole grains. That's an important vitamin for us. We'll talk about vitamins more in a minute. And then a lot of them are also going to have fiber if they're whole grains, right? It's whole wheat, oats, right, as opposed to processed grains. Vegetables and fruits are also sources of carbohydrates, primarily complex, but some of those simple ones, right, those sugars that we talked about, and they are very high in fiber. They are also very high in vitamins and minerals. They don't have a ton of calories because a lot of those complex carbohydrates in fruits and vegetables are fiber. They're non-digestible. We don't absorb them, right? So that's why when we talk about try to eat a lot of fruits and vegetables, the reason is because they're really high in vitamins and minerals, right? They're like little nutrition packets, right? They also have a lot of fiber, which we don't find as much of in some of the other foods we like to eat. They're not very energy dense. So if you're trying to be conscious about your weight or whatever, right, might be useful. But the more fruits and vegetables you eat in general, as long as you're eating other foods as well, that's excellent. Lots of nutrients there. What about protein? So we can kind of divide protein sources into two categories, animal-based sources and plant or non-animal-based sources. So for our animal sources, right, so we're talking milk and dairy products, eggs and meat. They're very high in protein, right? A lot of our body is made out of proteins, right? If you consume meat, you're consuming muscles of an animal. Very high in protein. They also have a lot of these essential amino acids. So we call these complete proteins, meaning they give you those essential amino acids that you need. Because obviously if it's an amino acid that I need, it's an amino acid that the chicken needed too. Okay, so we're going to find it in there. Unfortunately, they can contain a lot of what are called saturated fats. And we think saturated fats are associated with your increased risk of atherosclerosis, which remember is that hardening of the arteries, building of plaque on the inside of the arteries. Now there's some debate here as to whether it's the saturated fats themselves or whether it's which type of fats you'll find. And interestingly, if you have pasture-raised meats or eggs or milk from pasture-raised versus grain-fed animals, you see an increased quantity or relative proportion of healthy fats as opposed to the unhealthy fats. So if you've heard about omega-3 fatty acids and omega-6s, omega-3 fatty acids, which are the good ones, are present in high levels in the eggs, milk, and meat of pasture or grass-fed animals, whereas the omega-6s, which are the atherosclerosis-promoting ones, are more likely to be found in products made from grain-fed animals. So it's interesting. So meats also are high in iron, which is a really important mineral that a lot of us need to take in. Dairy products are also high in calcium, which is another mineral that we need to take in. And eggs are also high in iron. So a lot of other nutrients as well. Vegetable sources. So vegetable sources of proteins are mostly your legumes, your beans, and your peas, as well as nuts. Okay. Mushrooms, right? And soy products, right, because they're made from soy nuts or soy beans, right? So tofu, soy milk, all that kind of stuff. So you can get a lot of protein and therefore a lot of amino acids from plant sources. You have to, if you don't eat any animal sources of protein at all, you have to be a little thoughtful in terms of which protein sources you choose and make sure you get a variety, because you need to get all of those essential amino acids. And whereas a lot of animal products will by default be complete proteins, very few of the plant sources are complete proteins. They don't have all of, any one food doesn't have all of the essential amino acids that you need. One exception is spirulina. So if you're like, oh, my friend drinks these spirulina shakes or something, it's a complete protein that's from a plant-based source. That's all. It's not like it's magic. Okay. Lipids. So I said we need to eat fats, right? So where do we get them from? Well, again, there's animal sources and plant sources. In general, the animal sources tend to be high in those saturated fats, whereas the plant sources are high in the healthier unsaturated fatty acids, right? So that's your olive oil, your canola oil, avocado, nuts, seeds, olives, right? All these things over here are kind of your healthier fats. I mentioned you have to eat lipid in order to get essential fatty acids. So some foods that are particularly high in those essential fatty acids, walnuts, almonds, flax seeds, right? Salmon, eggs, olive oil, dark leafy green vegetables, so your kale, and pasture-raised meats again, right? So it depends on what the animal's been eating. That will impact the types of fat that you find in its products. So these are often called healthy fats, right? These are the ones you need. They're essential. So I mentioned minerals, and we talked about calcium and iron. What is a mineral? It's an element that you need to take in, right? So it's like it's on a periodic table of elements, right? It's not a molecule, it's a mineral. It's just this thing, right? So calcium, we need it for our bones. You probably know that already. We also use it for muscle contraction. So we'll talk about that later. And iron, you might remember, is needed to make hemoglobin, which is that protein that binds oxygen inside red blood cells so that they can carry oxygen around in our blood for us. And usually female-bodied people need to take in more iron because they bleed every month. So they lose iron in form of their menstrual periods every month. Sometimes quite a lot, actually. All right. We also need vitamins. So if a mineral is an element, what is a vitamin? A vitamin is a molecule that is not an organic molecule. It's not a lipid, a protein, a carbohydrate, or a nucleic acid that our body needs, but we can't make it for ourselves. So these are things we have to eat. Right? So a few examples. You don't need to pay attention to this. This is for people who are curious. So thiamine we need. It's found in whole grains. Vitamin A, which is needed for a pigment in the eye. So if you've ever heard, like, eat your carrots, they're good for your eyes, right? Well, you do need vitamin A in order to produce a certain pigment in your eye so that you can see properly. And then vitamin C is found in lots of things, but some of the biggest sources would be citrus and tomatoes. Vitamin C is interesting. So it's a coenzyme for a lot of different reactions, including the formation of collagen in the skin. So like flashback to when we're talking about tissues. So you'll remember we had the epidermis, the dermis, and the hypodermis. And the dermis was mostly composed of dense, irregular connective tissue, where we had collagen fibers going every which way, which gives us durability and strength in multiple different directions. Okay? That's why leather is so strong and so supple, because it is the dermis of an animal's skin, right? Those collagen fibers. So you need vitamin C in order to make good collagen. So what is the disease of vitamin C deficiency called? Do you know? Anybody know? Scurvy. You heard of scurvy? Aye, scurvy dogs. Right? So scurvy is vitamin C deficiency. And it used to plague sailors because they would go to sea for months at a time and they would be living on hardtack, which is like basically dehydrated bread. It's like a stone, and salted beef. So they weren't eating anything, so they had no fresh fruits and vegetables. They had practically no vitamin C. So they would get scurvy. So they would get these wounds in their skin that would never heal. Their teeth would start to fall out because the ligaments that hold your teeth in place are made of dense, regular connective tissue. And you can't make collagen. You can't make dense, regular connective tissue. They would also start to get easy bruising and bleeding because there's also collagen in the walls of our blood vessels. Right? So scurvy is vitamin C deficiency. and you get bleeding gums, and you get teeth that fall out, and wounds that don't heal. I actually had a friend who went on one of those like adventure trips, and she went hiking in the mountains of Patagonia in South America for 3 months, backpacking. They had one supply drop 6 weeks in. That is not my idea of a vacation. But anyway, right, so they had to carry all their food and everything for that whole time. Guess what they didn't bring? Fresh fruits and vegetables, right? Really heavy, not very energy dense. When she came back from that trip, she had scurvy. It was crazy. But anyway, so you need your vitamin C. How much do you need to eat? Well, you need to bring in enough energy to fuel your body to do its own maintenance and whatever activities you want to be doing. So you need calories, right? You need to pay the bills. And that's going to depend on what you're doing and how big you are. For most of us, about 70% of our daily energy requirement is just keeping ourselves alive. Right? Just making ATP so our cells don't fall apart, so we continue to pump that sodium out, that active transport to keep sodium concentration higher outside the cells than it is inside the cells. Right? Just keep ourselves alive. Then if you're really active, right, then you need more. So Michael Phelps, the Olympic swimmer, he eats 8,000 to 12,000 calories a day when he's training. Right? So he eats 6 times the volume of food that I eat. Right? You also need enough fiber to stay regular. You need enough protein to get your essential amino acids, which for most of us is 3 to 4 servings per day. If a serving is 3 to 4 ounces, which is the size of a deck of cards, which is quite small when you think about the servings that you get at a restaurant, right? We need enough lipids to get our essential fatty acids. So if you're eating walnuts and kale, right? If you're eating butter, you probably need to eat more of it. And then enough of the right foods to get all of our requirements for our vitamins and minerals. So in order to figure all that out, it's actually a lot of calculations. And that's what people who major in dietetics study, right? So that's really complicated. So instead, let's just do this. Right? So this is kind of a good general guideline when you think about what's a healthy way to eat. In general, about half of your plate should be fruits and vegetables. And people are like, oh, darn. Right? And about the other half of it should be greens and protein. And a little dairy for your calcium and some extra protein and lipids. Right? That's actually a pretty good guesstimate and guideline for most people. How do you know if you're getting enough? We have this awesome system built into us called hunger. Okay? So, oh, and interesting, so my friend who went on this backpacking trip who was not getting enough nutrients, right? She had bona fide vitamin deficiency when she came back. She also came back 20 pounds heavier, right? Even though she was hiking, carrying and kayaking through Patagonia, right? She came back 20 pounds heavier because her body wasn't getting what she needed, so she was hungrier, so she would eat more. That's the body trying to get what it needs. Yeah? All right, so hunger. Energy levels. Do you feel tired all the time? Well, who doesn't, because it's the middle of a pandemic, but, right? During normal times, if you just always feel really logy, you might not be eating enough. So if you're an athlete and you've heard of relative energy deficiency in sport, that's what that is. You're not getting enough nutrition in for your needs. So you feel tired, logy, you might have bad times. Good circulation, normal menstruation, right? Healthy bones, all those things we talked about, right? If your hands and feet are always cold and kind of bluish, your body might be trying to conserve energy, right? Meaning that you're not getting enough. How do you know if you're getting enough protein? Well, it's really rare for an American to be protein deficient. We eat a lot of protein, okay? But in other countries, sometimes you see the pictures of starving children in other parts of the world, and they have these really big bellies, right? It's well, why do they have these really big bellies if they're starving? That is a sign of protein malnutrition. What happens if you don't get enough proteins is you accumulate a lot of fluid in your belly. That's not fat. It's just fluid. Okay? All right, so you don't have to worry about protein if you're an American. Lipid requirements are also not a problem for most Americans, but some people take healthy eating too far, and they won't eat anything with fat in it, right? Some people get really restrictive about certain types of nutrients. We call that orthorexia, right? They won't eat certain things, and that can be a problem. And for vitamins and minerals, there's no great way to tell if you're getting enough unless you develop symptoms of a deficiency, like scurvy. So it's kind of tough. So this we just tell people eat a wide variety of healthy foods, and then you should pretty much get everything. Most people don't need to take a multivitamin, but if you're living on ramen noodles and pizza, maybe a multivitamin would be a good idea. Okay? All right. Iron deficiency can be very common in people who have heavy periods. All right. So with that, I'm going to end for today. Any questions? Gonna let you go get a snack. All right. Have a good day, everybody.